Hey, how's it going there, chemistry student? Welcome back. Today's lesson will be descriptor 1.5, part 1. I can determine the density, including correct units, of substances from a graph or in a lab. If we look at our descriptor sheet, 1.5 is located here at the bottom, and that's the one we'll be going over today. All right, let's toggle back to the notepad and let's start talking about density here, okay? So when I think of density, an equation pops into my head, okay? And this is the equation I get. D is equal to M divided by V, right? So what do these variables stand for? The D stands for, you guessed it, density. M stands for mass. And V stands for volume. Density as a whole is a ratio of mass divided by volume. And a ratio is just a fancy word for a simple fraction. Now let's recap the words mass and volume using a simple example. So here I have an elephant and a mouse, and the elephant is carried the mouse, right? That's apparent. And there's two questions we can ask ourselves, okay? If I look at these two animals, which one has the larger volume? Well, when you think about volume, you think about the overall visual size, right? So which one has the biggest overall visual size? Well, you guessed it. It's going to be Mr. Elephant over here, okay? When we think of the word mass, we can't necessarily just assume that one object weighs more than the other, but from our experience, we should know that the elephant definitely has a larger mass. If the elephant stepped on a scale, its reading would definitely be bigger than that of the mouse. All right, so just to recap, if we know an object's mass, and I know its volume, I can divide those two things and come up with the density. All right, so below here is an example that you'll most likely see in your chemistry class, and here's what it reads. Mr. Laudermith dropped a rock into a graduated cylinder filled with water. The water level was originally at 20 milliliters. Now the water level is at 30 milliliters. Mr. L knows that means the volume of the rock is 10 milliliters. Okay, so what else would he have to do to find the density of the rock? Explain. To find the volume of the rock, we know that we're somehow going to have to divide mass by volume. When we think of finding volume, there's two categories we have to really think about. Is the object a regular or irregular shape? The reason we have to think of it in these terms is because there are two separate procedures to figure out volume. A regular shaped object will either be a cube or a rectangle, okay? So any kind of six-sided geometric shape, and what we can do with geometric shapes is multiply the length by the width by the height. So let's write that out. Length times width times height. So now what would I do if the shape of the object did not conform to a geometric box? Well, what we would do is we call this now an irregular object, and there's a whole separate procedure that we need to follow to measure out this new volume. The procedure goes as follows. We're going to need a container full of water. The container has to be one with indicated volumes on the side. What we're going to do is record the volume initial, and after you put in your object, so let's say here's a little rock, we throw it in, this volume will actually come up, and we'll call that our volume final. So an everyday example that helps really visualize this is taking a bath, right? So some of us like to take baths, and if you kind of look at the left over there, you see there's a bath, and ideally this would start getting filled up with water here, right? And You usually fill it up towards the top, but you never let it get to the top. If you let it get to the top and you went in the bathtub, you'd get a picture like we kind of see on the right. The water would overflow. And why is that? Your body has a certain amount of volume. If there's a lot of water in the tub, your volume will displace the water. It'll spill it over. You take up physical space, okay? The same concept kind of applies to measuring any object for volume. When you put an object into some sort of measured container, the water level again will jump up, okay? So to find the volume, there's another equation we need. Volume is equal to volume final minus volume initial. So let's look at the example again. So it says the water level was originally 20 milliliters, and the water level jumped to 30 milliliters. So let's fill in these numbers here. So volume final was 30, volume initial was 20. 30 minus 10 gives us 10 milliliters. This is the volume of the object, and that's actually what it states in the problem. The volume is 10. The difference will give us the volume. So we'll throw in a little 10 here at our ratio so we remember. And now we're ready to tackle the final piece of the problem. What else would we have to do to find the density of the rock? Well, we know that what we have left is find the mass. So what we would definitely need is a balance, right? You would put your rock on the balance. The balance would give you a readout. So let's say in this case it was 1.5 grams. I could fill in the number here at the top, all right, arbitrarily, as an example. And all I would have to do to find the density now is divide 1.5 by 10. So let's go ahead and do that. So I have my trusty calculator, 1.5 divided by 10. It comes out to a decimal. The decimal is 0.15. I need to add some units here to finish, and my units will be grams per centimeters cubed, right? And let's highlight this so we can see it a little bit better. This here would be our final answer. So to conclude and wrap up the question, what else would Mr. Laudermilk have to do to find the density of the rock? If he figured out the volume, he would have to go grab a balance, put the rock on the balance, figure out the mass, and then divide the mass by the volume to get an answer similar to what we came up with on the screen. If you're feeling comfortable with this concept and video so far, what I would do is move on to lesson 1.5 part 2. If not, I would rewatch the video and watch the supplementary videos that are attached to the screen. Thank you, and we'll see you next time.